in 1863. And that was the height of the Civil War. And DuPont was making a lot of gunpowder for the Union Army. Okay, so they needed the extra power. And what it did was power at the pack house that was 70 feet behind this building. And in the pack house, there's this big sifting machine called a bolter. And that bolter would sift out dust. It also could regulate the size of the grain depending on what kind of powder you needed, whether it was cannon powder or rifle powder or blasting powder. You had different size grains. So that's the machine that operated mostly. What the year this machine came, there was a big explosion. They had 1,000 kegs. Each keg, 25 pounds of powder, blew up in that building. They heard it in Philadelphia. They threw stones from this building and that building as far as the front gate, almost a mile away. The worst part was that 13 guys lost their lives. And that was one of the 288 explosions they had over a period of 119 years. Most of the explosions there weren't any casualties. They were in the roll mills. That's one of your next stop down here, the roll mills. Those roll mills, when they were operated, there weren't any men allowed down in that area. So, the pack house last blew up in 1915, and they never rebuilt it because black powder had become obsolete, pretty much, and then these yards were becoming obsolete. Maybe because of things like the steam engine, you could go anywhere and bring that back. Right? So let's talk about this one. What does this remind you of? Anybody have any idea? Yeah. A year? Anything else?
Locomotive.
A locomotive, yeah. As I say, it's a locomotive style boiler. It could be used. Now, of course, it doesn't have the wheels, and it doesn't have the engines in front of the wheels like on yours. Well, we'll see. You'll see in just a second. The engine's over here. With this thing, this is the boiler, and all we're doing here is boiling water. We have wood that we burn, and then mostly coal after we get it started in the firebox. This middle section is the water box. 300 gallons of water we start with. Through that water, there are 54 tubes like this one, through which the hot gases and smoke travel, and exchanging heat to the water, producing steam that collects in the steam film right here. You have those hot gases and smoke come out into the smoke box and out the smokestack. So the steam has to get over to the engine, and that's why we have this pipe insulated with wood slats, typical today. And here is our engine. Okay, and Debbie's going to turn the engine on now so we can see how it works so this guy's satisfied. Okay? There we go. Now you have one cylinder there. It's only one cylinder. And the piston's 9 inches diameter. It travels about 12 inches. Every stroke is a power stroke, unlike the modern cars, where every fourth stroke is a power stroke, right? So everything else being equal, this is like 4 cylinders. It's still only 10 horsepower. Okay, the thing that's spinning there is what's called a globe governor. And it's kind of like cruise control in a car. As that thing spins faster, it's in time with the engine. When it spins faster, the globes go out, and they shut down the steam. It's set at 60 RPMs. And so this, no matter what the pressure is up here, it's about 20 right now pounds per square inch. This, no matter what the pressure is, this will only go at 60 RPM, revolutions per minute. Okay, so you got the piston going back and forth. Again, every stroke a power stroke. You got the piston rod, connecting rod. This red thing is a crank, just like on a bicycle. You have pedals attached to a crank, and when that crank is turning linear motion, back and forth motion, into circular motion. You've got an offset cam here that operates the valve that lets the steam in and out. Just like the cam in your car engines that lets the fuel in and the exhaust out. This is letting steam in and steam out of the engine, of the cylinder. The big wheel turning, that's a flywheel, 1,800 pounds, almost a ton. It doubles as a pulley using a laminated cowhide belt, going to a secondary pulley, half the size, plus the RPMs. Here we have a clutch pulley. You can push on this lever, that fork will move the belt over onto an idler pulley, so you can shut off the operation up in the pack house without shutting the engine down, just like a clutch in the car. You have another laminated cowhide belt, pulley, line shaft to the window. It stops there. Back in the day, we've gone another 70 feet up into the pack house. Now, there's the Birkenhead Mill right down here, 250 yards. They could do the same work that this thing did. They prefer using the water power.